So in this video, we're going to talk about what a function is. So we're going to start with the definition of a function. So the definition of a function says given a relation in x and y, we say that y is a function of x if for each element at x in the domain, there's exactly one y in the range. So that means each x has exactly one y. There are no two ordered pairs that have the same first coordinates and different second coordinates. So we talked about the x, y coordinates. And so sometimes we'll see them in a table form. Sometimes we'll see it in a list form. And so I have 4 problems here, and I want to just show you which of these defines y as a function of x. So sometimes it might be easier if you want to put the pairs in a table form. So the ordered pair 1, 3 would be written like this: 2, 3, 3, 3, and 4, 6. So does this fit the definition? Each element in the x, so these are the first coordinates, there's exactly one y value. So 1 has the 3, 2 pairs with 3, 3 pairs with 3, and 4 pairs with 6. This fits the definition. There are no, so in the 2 ordered pairs, the same first coordinate, there are no duplicated x's here. You have no 2 ordered pairs may have the same first coordinate and different y's. So that fits our definition. So this would be a function. This one here, when I put it in my table form, looks like there are 2 x's. So duplicated. So the 2 and the 2 here. And they both have different second coordinates. So this one here would not fit the definition. So this is not a function. Take a look at the third one. Here I have, and it looks like, let me erase this. It looks like my points are a little bit off. I'm going to erase this and I'll just write them in. Sorry about that. So let's say that we had 1, 4, 5, and 3. So we have 4 pairing with 1. That's okay. 6 pairs with 4 and 3. That's where the problem is. The first coordinate cannot pair with 2 different y values. That's mean if I wrote these as ordered pairs, the 6 would pair with 4 and 6 would pair with 3, and I have the same first coordinate pairing with different y values. The 10 pairing with the 3 is fine. So this would be not a function. And then the last one here, we have the Lakers pairing with California, the Spurs pairing with Texas, the Mavericks pairing with Texas, the Clippers pair with California. These are all separate x values, or the first coordinate, and they pair with a second coordinate. As long as the x values, or the first coordinate, is different, then, and no duplications here, then we're going to say it's a function. So this would be yes, this is a function. So that's how to determine if we have a function. So when you go to ALEKS and you take a look at the problems that are listed there, you have some that have, they'll say domain and range. Domain refers to the first coordinates. The range refers to the second coordinates. So let me write out what I just said. So I said that the domain is the set of the first components in the ordered pairs. It is the X values or the input values. And I don't want to just use X and Y because they're not always listed as X and Y. So the input values. The range, this is the set of the second components in the ordered pairs. That's our Y values, or you can say the output values. If you're asked to determine the domain and range, let's go back to the problem we had initially. This was our initial problem, and we were asking ourselves, is this a function or not? If the question had asked me to identify the domain, I would say the domain is the points 1, 2, 3, and 4. So it's a list of the first coordinates. And the range would be a list of the second coordinates. Now in the second coordinates, I do have some duplicates. So I do not need to write those duplicated. I don't have to write 3, 3, 3. I would just write 3 and 6 are in my range. So in ALEKS, you're going to have the problems will list the domain and range, and then you will be asked, is it a function or not? So you're going to need to answer those type of problems. So very similar to what I showed you. Now another way to determine whether you have a function or not is to do what's called the vertical line test. So let me show you that. So it says what a vertical line test is if you have the graph or you have points that are plotted. If no vertical line intersects the graph in more than one point, then you can say it passes the vertical line test. So I have some problems on the page here, and we want to know, looking at these, would it pass what we call the vertical line test? So in this first one here, I'm going to take, and what I do is I'm going to draw vertical lines through it, the graph. So this blue line is my graph, and each vertical line intersects in only one spot. So I can say, yes, this passes the vertical line test. I'm going to abbreviate it, VLT. Now, if I had a graph that looked like this, so I'm going to say, yes, this passes the vertical line test. And so since it passes the vertical line test, it is a function. Now, if the graph looked like this, when I draw vertical lines through it, notice how it crosses in two spots. This is not a function because it fails the vertical line test. So take a minute and pause the video and take a look at the rest that I have on the screen and see, of these three that are left, which ones would you call functions and which one would fail the vertical line test and not be a function. So I'm going to continue now in the video. Hopefully you paused it and took a look at it. And so for this one, I just have points. And so each point, though, lays on its own vertical line. So this one would be a function because it passes the vertical line test. This one, not a function. It fails the vertical line test, so not a function. And so if it fails, even if it fails only in one section, it's still not a function. So maybe it would pass if you had a graph. Let me draw a different one here. Let's say we had this graph. And so when I draw the vertical lines through, well, it fails here, but it doesn't fail here. So I would still say it's not a function. So unless I restrict it to a certain area, it would not be a function. And then the last one here, wherever I draw a vertical line, it only crosses in one spot. So this is yes, a function.